thank you very much. Good afternoon, everybody, evening. And we are here for, it's a tough act to follow, Kanchana particularly, but we're here for the IAB technical plenary. And we're here to talk about a new class of attacks on the internet architecture, or perhaps just some insights we hope are new. As pretty much everybody knows, there was an attack on the internet infrastructure on October 21st that compromised access to some well-known resources and caused an explosion of attention on DNS, the Internet of Things, mass compromises of internet-connected devices, and the business and operational models underlying the provisioning of content at internet scale. The IAB were preparing an entirely different tech talk, but there was an immediate sense that there are some ideas to pull out of this experience, so we switched tracks in order to address some of the potential insights under the surface of a headline-making incident. Nobody wants to be in the middle of such an incident, but afterwards, there should be things to learn. As a DNS person myself, for instance, I spent a lot of time in those first few days answering a lot of questions about how the DNS worked, how the internet works, and trying to correct some of the more alarming things that people were saying. But pretty quickly it was obvious that there were things to learn here that went beyond one large provider's no good, very bad day, or the challenges in providing one particular service to the modern internet. This was an attack on part of the internet architecture itself. So we asked Nick Sullivan to come and talk with us from Cloudflare. We also asked our own Andrew Sullivan to speak to the subject, both because and in spite of him being an employee of Dyn, the provider who was attacked, and an IAB member. So he's here in both capacities. But we're hoping both of them will provide some insight, some perspective on mass-scale internet attacks. But primarily, we think there's some underlying and concerning observations to make here, and would like to see some discussion of the implications of perhaps new insight on vulnerabilities of the architecture of the internet itself.
Okay, hello everybody. Thank you for having me. I'm Nick Sullivan from Cloudflare. I'm going to kind of go over some lessons that we've learned in terms of, this is moving on its own, in terms of dealing with large attacks and really staying online. So the talk's called How to Stay Online, and it starts with a little bit of a dark tone, but DDoS, it exists, and it's going to be part of all of our futures. And running infrastructure is difficult, especially in a hostile environment. And I think the main reason that I'm here can be described in this Twitter account. If you follow it, this shows the Mirai botnets and all the attacks as they go on live. And this is not something particularly new. Botnets exist. They've existed for a long time. This is just an example of botnets at a larger scale. And they send a mix of attacks. So when you think about DDoS, or when you talk to someone about DDoS, this is really what you think about generally, is this sort of reflection amplification attack using some amount of compromised machines and reflecting off of a protocol that does not validate source address, perhaps using UDP. NTP and DNS are two of these examples. And this still goes on, but it's not really the majority of the type of attacks that we see nowadays. So what I'm going to cover here is the popular attacks we see now in 2016. What are people actually doing? And these break down into three main categories. Some of these are old. Some of these have been around forever. They shouldn't be new to anyone. But I'm going to describe ways that when you see attacks of these types at magnitudes that are very large, what you can do. So DNS floods, SYN floods, HTTPS floods. I don't have to explain to anyone in this room how DNS works, but when it comes to attacks on DNS, there are two main types. First is direct attacks on the authoritative DNS server from a botnet. Second are attacks that go through valid recursors and are laundered by these recursives before they move to authoritative DNS. The first set are typically larger volumes than the second. Direct to authoritative. The question is, if you're faced with a flood of requests at your authoritative DNS and they're not from resolvers that you know, then you should be very suspicious. The DNS architecture is built to go from these endpoint stub resolvers to the recursive resolvers to the authoritative DNS. And if you see a lot of packets and a lot of requests, you should probably just drop them, and this is potentially safe. And this is really the only way to stay online for direct to authoritative attacks. So what do these floods look like? Typically, these are requests for your apex domain, your www domain, or random subdomains of these two. And the reason that they go after random subdomains is that it costs more for you to look it up as a DNS server. Sometimes they come with spoofed addresses, source addresses, sometimes not. In the case of the Mirai botnets, they're oftentimes not spoofed addresses, which makes them slightly easier to deal with, but not by that much. DNS Flood Survival Kit. So this is one idea, this is one thing that used to be done quite a lot for actually protecting against these type of large attacks, and that's null routing IPs. You take the IP that's under attack and you advertise it upstream so that it basically falls off the internet. This is a pretty dangerous thing to do, and it has lots of repercussions. Lately, attackers have been flooding entire subnets, making this very unreasonable in terms of a defense mechanism. Furthermore, these glue records that you use to point to your DNS servers, they have long TTLs, and changing them is not something that's very feasible at the moment. So this is not something I would recommend at the current point. But there are two main techniques to keep yourself up if you're running this sort of authoritative DNS infrastructure. The first is spreading the load, and then the second is filtering. Filter fast and filter often. One way to spread the load is to run an Anycast network. This allows you to spread the load geographically. Network hardware does not scale linearly in price. If you have a 10 gig piece of hardware, it's not going to cost 10 times more to buy a 100 gig version. It's really horizontally, if you can make sure that the amount of traffic at each of your data centers is low, it's cheaper, it's easier to handle. Spreading the load not only geographically, but within the data center, ECMP is a good way to do this. Filtering packets, going down from the top of the rack to the actual DNS application, filter as early and as soon as you can. There are different mechanisms you can use at different levels that can handle different amounts of packets. If the request gets to your DNS application, you might as well just answer it at that point. So the main way to handle a large flood is to make sure that only legitimate packets get to your application. There are a number of ways of doing this. One is IP tables, BPF rules. These are very powerful techniques that you can use to match and block packets inside the kernel. And these can be automated, which is very important. There are tools, open source tools, to create BPF rules that match attacks, but this is not something that works with a static configuration. You really have to move fast and change them very often, because if you have too many rules, it can cause problems in other situations. So heuristics, machine learning, attacks change. The attacks that you're going to see from one botnet are not the ones that you're going to see from the other one, and it's going to change from time to time. So this has to be very dynamic. But you do have the ability to sample from different places to see what the types of attack signatures are and figure them out. Some of them are very easy to identify, some are more difficult. But if you have static rules, you're probably going to go down. And if possible, move the rules outside of your server and move them into the network interface card. This can really help relieve the load. DNS floods are sort of very closely tied to this other type of attacks, which are attacks that go through the recursor. This is in which attackers will, from their botnet, send DNS messages that end up at your authoritative server, but they go through recursors. This is very different. You do not want to block and drop these attacks. The right response is to answer. Recursive DNS is making requests for legitimate customers, and they treat however you answer their requests as relevant state for them. So if it's possible to whitelist known recursive DNS servers, do so. This is very helpful and the right thing to do, because if you rate limit, this can cause some negative effects, including an amplification of the request as the recursive servers try to test to see whether you're back online or not. So rate limiting is not a very effective method for this. Really, you have to handle the packets. One technique that was suggested for this is every request that comes through, this is also randomized subdomains, so they bust the cache of the resolver before they hit you. And if you can, there's a technique in DNSSEC called the NSEC record, which is a cache of a negative answer. Currently, you can only, in the resolver, cache this for negative ranges. Potentially, caching this for non-signed ranges might help. Just one of many different options of keeping the traffic from going all the way through to the authoritative server. DNS attacks are not the only types of attacks. What made this botnet and a lot of the current attacks very damaging is that they go through multiple protocols and multiple types of attacks. SYN floods, this is classic. This has been around forever, but it's still very effective. If you don't configure your TCP stack perfectly, it can cause some serious problems. Using BGP Anycast on the TCP side also lets you say, I understand which regional, non-regional IPs you should expect SYN packets from. And there are IP tables, BPF rules that you can build for this as well. So SYN floods, also very difficult to handle, but they're often mixed with the DNS attacks. HTTPS floods, this is much more common. This takes up server resources by sending HTTP requests over an established connection. The good thing about HTTP is it handles rate limiting very well. You can rate limit by request, rate limit by volume, and for these types of attacks, a simple TCP reset will get you a long way. If the attack is HTTPS, the attackers may try to take advantage of some asymmetry of the cryptography, and there are ways to mitigate that using elliptic curves as one. There are proposals for things like client puzzles, but those are not implemented. So these things are all mixed together, but who is attacking us, or who is attacking the internet's infrastructure? Generally, this is compromised endpoints. And if you think that this is going to get better before it gets worse, we haven't seen the first major IoT worm yet. We're in the early days of this new set of devices that are running software, and this software is getting old on a lot of these devices. So it's probably going to get worse, though there are ways to think that it may end up getting better. One key thing is if there is a viral aspect to this. So if you have a device that's going to be compromised, it has to be found to be compromised. IPv6 has a place here in making things difficult to find by scanning the entire internet. Building these IoT devices is really closely tied to the economics. Margins are very thin. So things like a secure by default open source software, if that was available, people would use it. Investing less time in development helps your margins. Secure firmware update life cycles, these things are very hard. As we've seen from the Windows desktops to iOS to Android, it takes a long time and a lot of perseverance and a lot of developer effort to build these ecosystems that allow you to update these software. software pieces. It's not clear that in the IoT case that this is something that is in the near future. Another piece is attribution. If you know where the attacks are coming from currently, source IP is something that can be spoofed. NetFlow is something that can help identify real sources, even without source IPs. This is something to think about. Now, I've kind of described some technical ways to protect against DDoS, and these shouldn't really not be new to anyone here. These are the same problems we've been facing for years and years. They're just now at a much larger scale. And it's exposing certain things about the internet itself, and things that we've known, which are that the internet has choke points. And as attacker bandwidth grows, they can target these choke points. And things like Anycast, things like being able to stop the attack as close, or stop bad traffic as close as possible to the edge of the network or the entry point of these attacks is very valuable for actually protecting these choke points. Anycast is just one of these techniques that allows you to do that. If you're subject to an attack, keeping your costs down are very important, and this is the only way to really sustain a large-scale enterprise is to not have to pay a lot of money for these very large attacks. Luckily, many internet protocols are asymmetrical, and they have great caching semantics, broadcast, HTTP, for example. So you have extra capacity on ingress if you're using multiple protocols in the same data center. Scrubbing centers, sometimes these can be very expensive because they're single use, and you pay for the maximum of the bandwidth. So it's good to spread things out. Keep things spread out and distribute the load and filter early. And this is sort of a sunny final end to this, but I wish it wasn't this way, but staying online now requires scale. So this is something where you have to be big, you have to be smart, and you have to have tools. And you have to work together with other people to try to stop the attacks close as possible to the edge. And the techniques I described here try to approximate this as much as possible. It is possible to survive these large attacks, and it is possible to survive in an internet ecosystem in which attackers have exceedingly large bandwidths. But this involves really paying attention and doing things right on multiple levels, all the way through your stack, and thinking about your architecture and building things so that they can handle it. And that's the end of my sunny presentation. Thank you.
And we'll find the other. I was thinking of Nick's, thank you very much, Nick, and I was thinking of this as sort of the setting of the big picture, and I guess we'll have Andrew draw in some details and some finer points, and then we'll have your questions and comments.
If I put a clock here, then I won't just talk forever. So I'm Andrew, for those of you who know me as the chair of the IAB. I also work for this company called Dyn. It's called Dyn, not Din. That is dynamic rather than the noise that you heard when everything broke. We had a bad day recently, and and I think
Take two, they're small.
I have the wrong version. There are two of them up there. This looks just like what I put up.
No, that one's mine.
That one's his. He's also Mr. Sullivan.
There's no relation.
This is the problem with naming, you see, that you need unique names. We should have had a hierarchical system and then everything would have worked. So I want to talk a little bit about what happened during this bad day, and then I also want to talk a little bit about what it means for the internet architecture. And I think there are a couple of things that I want to say here. I mean, the first thing is that there was a large number of devices, but the attack is really against some desirable attributes of the network. And I think that this kind of, or this style of attack actually could attack a bunch of regulation, or could attract rather, a bunch of regulations towards us if we're not careful about it. And so what I would like to argue today is that we should actually do something about this ourselves. So what happened? Okay, well, these were attacks against some Dyn infrastructure, and it was noticed because there were some systems that depended upon us, you know, customers. And that's what happens, you know, you get one of these things. Nobody knew about us at all before this event, and our marketing people are really of two minds about this whole thing, right? I, however, didn't want to know. Now, I want to emphasize that I didn't do any direct work on this because I've been an internet politician for the past 2 years, and so I'm now useless to my employer. What this meant was that our NOC and the operations people did all the work, and like, you know, NOCs and operations people do whenever there's a crisis, they did a great job. So I want to thank them, and also a couple of people at Dyn, Chris Baker and Phil Stanhope in particular, fed me some of these things. So they fed me this stuff, but of course the conclusions are mine and all the mistakes are mine. In any case, this led me to some questions about the DNS infrastructure. Now, our infrastructure is an Anycast-based system that is mostly transit-driven. There are reasons for that, but the primary thing is that we did this because we had a system that allowed us to do certain kinds of management to avoid exactly this kind of problem. It didn't work out in this case, but in the past it's worked very well for us. And the point of this is to get this this system, which is fairly large. It's in 18 sites, and the diversity of this thing was arranged in such a way that you didn't tend to have this kind of problem. So what happened? On the 21st of October, about 11:10 UTC, we had a thing start up, and it was like a normal DDoS, and these happen all the time. It was targeted, you know, across our systems, and the NOC started doing the usual runbooks that they always do for this kind of thing, and then suddenly the whole thing changed, and it moved to this U.S. East region. You know, we're doing the same DNS tricks that everybody else is doing in this area, so we've got these regions, and what happened was there were way more addresses than normal, but also the attack pattern was a little different than normal. I'm going to talk about that in a minute. So this caused some resolution failures, that is, things just didn't get answered, and also it caused some long latency on things, which those of you who are familiar with the DNS, you know that if the latency is long enough, it's just like the thing isn't there because you just ignore it. This lasted until about 13:20 UTC. And then we had another one. So this, you know, we put in some mitigations, and the mitigations worked, and the attack stopped. And they were mopping up the way NOC always does, and of course, while they were mopping up, another attack started, only this targeted all of the servers in the world that we had. So we knew a little bit about how this thing had worked, but of course we hadn't actually made the changes globally, so naturally it was still widely observable. This we recovered by about 1700 UTC, but there was some sort of hangover that we still haven't completely figured out what happened there, but there were some resolvers that weren't able to reach us, and they were not small, obscure resolvers. One of them is operated by a company that used to start with a G. So what was unusual about this was actually that, you know, we've seen lots and lots of sort of standard amplification attacks, but this particular attack had a really, really high proportion of TCP, and we don't normally see that in these kinds of attacks, because normally it involves a lot of state on the attacker side as well, so they don't do it. And there's very little spoofing in this, or I shouldn't say very little, but comparatively low spoofing. We have definitely confirmed 40,000 addresses involved in this botnet, but maybe something like 100,000 addresses in the botnet. Now you're probably saying to yourself, gee, that's not a very big botnet. But think a little bit about DNS and TCP and what happens when you've got 100,000 members of your botnet and they're all opening, say, 10 TCP connections to your DNS servers, and you can see how this thing can expand fairly quickly. The other thing about this was, of course, as we started to have problems, we've never had this problem before, but the recovery retransmissions by some of the resolvers actually served as a sort of second front. So we got this sort of second wave amplification, which caused us some problems. We definitely had a Mirai-based botnet. We've done a bunch of forensics on this. We've identified pretty much where these things were and not who was behind it. And we still, as I said, don't exactly understand what this hangover was, but it did cause a sustained outage even though everything was up, and we haven't completely explained that. I want to emphasize that I do not believe this was a one-off. There was a previous attack just a couple of weeks before this that was very, very large. We know that the Mirai botnet code is out there, but it's being improved upon by various people, but it's not the only botnet code that's out there either, right? I'm sure you all have your favorite DDoS example. So what showed up in the press was Internet of Things takes down these people, and that's what the problem is. Internet of Things is bad and evil, right? So it's a Mirai botnet, and those of you who aren't familiar with this, that's using these Internet of Things devices that are easily compromised. And there was an Internet of Things dimension to this attack, but I really want to emphasize, I don't think that that's the main story. Because this attack pattern uses the very thing that makes the Internet strong, and it's using it to attack the way the Internet works. I think that this is an irony, right? What we've got here is an attack of irony against the Internet. It's astonishing to me. So back in the easy time, what would happen is the attackers would, buy a bunch of things in some provider. They would, go and check in Kata or something like that and make sure that spoofing was allowed from there. And then they would set up their botnet, and they'd have their botnet army, and they'd send you a lot of stuff. And this was, typically UDP, and there was a lot of spoofing and so on. These were cheap and effective. But what happened, of course, is that people got better at scrubbing, and they got better at soaking these things up because, you just outrun them. And it turned out not to be that hard. The cost of transit's going down, cost of processing's going down, and so people said, well, we'll just win this thing forever. I remember actually being mocked a couple of years ago when I said that you're going to run out of money before they run out of compromised hosts, and everybody said, no, we'll beat them. Well, I'm afraid we're here. So the first answer to all of this is to get really big, right? This has been the answer. What you're going to do is you're going to have like lots and lots of Anycast, and you're going to have CDNs all over the place and everything like that. And what I'm worried about here is that what we're building is no longer an intranet but an oligarchonet. That you can't actually participate in running services online unless you get really huge, or at least large enough that you're spending a significant amount of money on your infrastructure. That doesn't seem to me to be the internet that I thought I wanted to build, and it might be that that's the thing that we've built, but I think we better ask ourselves whether we should be so proud of that if that's what we've got here. There are problems with this. It creates monoculture. It creates the associated security problems. It also means, of course, that the distributed nature of the internet that we keep talking about is no longer true because you've got these giant providers who are involved with everything. And it makes for high barriers to entry, and I don't think that that's a great arrangement. Nevertheless, I think it's obvious that the Internet of Things is going to continue to create these kinds of problems. It encourages this ubiquitous connectivity, and even very, very lightweight systems, things that are not very powerful, have enough power to open a few TCP connections and so on. And you know what they used to say about the budget, right? Like $1 billion here, $1 billion there, pretty soon you're talking real money. Well, the same thing is true here. If you've got, millions and millions of these devices all over the place, you're going to have a lot of compromisable hosts, and they make that available. The other thing, of course, I want to point out is that people talk about the Internet of Things here, but it isn't only that, right? A lot of the devices that we're talking about aren't really Internet of Things devices so much as there are just consumer devices, and they're intended to connect to anything at all. So they don't have a hub, they don't have a home that they call back to or anything like that. They just connect to anything they can, and those things are compromisable as well. Now, the vulnerabilities are pretty bad. One of my colleagues did some work on this and discovered, I mean, we had like 4.1 million unique A records hanging around, so he did some poking at it. He found 10% of the devices in the sample were affected. Now, 300 devices doesn't maybe seem like very much, but of course, this was only 4.1 million IP addresses, which also isn't very much. The other thing, though, that he noticed, and he put this on a slide that he presented somewhere, was this use case encourages owners to open them to the internet. This really bothered me, because it seemed to me that the whole point of this was to connect everything to the internet. That's why we're here. And so if our answer to this is, well, we really need to discourage people from connecting things to the internet in order to prevent the security from getting out of control on the internet, then we have failed completely. So remember that we had this dumb network that we wanted to build. We wanted to maximize the intelligence at the edge. You could still have a dumb device or whatever, you know, these Internet of Things devices aren't that smart, but they're still supposed to be smarter really than the network. They're not, the network's not supposed to be making the decisions. This is, you know, it's got all the usual good stories, you know, the permissionless innovation at the edge that we all talk about and so on. The problem is that this is what makes for the attack that we're talking about. It's a really bad story when those end devices can attack you. And it's not just compromisable things, right? You know, you could do this by leaving a lot of devices in coffee shops all over the place, and they're all perfectly secured because they're controlled by the bad guys. That'd be another way to run this attack. You could do this by compromising a whole bunch of you know, machines that have not been updated in a long time, and they've all got ubiquitous connectivity. That's another way to do this. There's lots and lots of ways to do this. The insecurity of devices is not the main problem. It's not DNS or UDP specific, so things like BCP38 don't solve it. And if you add more providers, it doesn't automatically solve the problem. It just causes more barriers to entry, because what happens is you're in an arms race, and you're in an arms race against people who have an infinite supply of hosts that they can throw at you. I've heard people already making actual proposals like this. So the first one, of course, people said, well, the government should mandate BCP38, which wouldn't even have worked in this case. So, so that's not a very interesting thing. There are people who want to give licenses for connections either to devices or to humans. That'd be a fun thing to do. We'll get a global, worldwide internet license police. I've definitely heard people talking about, and I think this is coming, folks, so be ready for it. I believe that people are going to implement the submission port for DNS. So large recursives are going to get preferred access to authoritative servers, and everybody else is going to have to talk to through some recursive. If you think that we have a problem in the concentration in the mail world, imagine if we do that for the DNS too, and now we have changed you know, the nature of the internet quite a lot. There are lots and lots of things that we could do in order to reduce the openness of the internet in order to solve this problem. Now, 50 years ago, there was a big change to the automotive industry. Prior to the publication of this book by Ralph Nader on Safe at Any Speed, I mean, this book is mostly famous for destroying the Corvair, right? Corvair was a car in North America, and it destroyed that. But the more important thing that this book did was change the nature of the automotive industry in North America. From an almost completely unregulated system where people could build stuff and they just, you know, put them on the roads and no big deal, into a very heavily regulated industry. And people, even automotive industry people, so I got a quote from him, right? Bob Lutz, who was a big automotive industry person, he has now come to believe that this book had a seminal effect because it made sure that there was definitely a role for government in automotive safety. Bob Lutz, who opposed every single one of the regulations that came from this, he still thinks it was a good idea. Transformative technologies, like the automobile and like the internet, attract attention from cultures. And the culture, if it's transformative enough, the culture says, okay, we're going to let you in, we're going to make our lives around you, but what we're going to do is we're going to extract rules about what you're going to do from that. We're going to start imposing rules on you. And I think that the internet is at that point. We're facing it now. I think there are things that we could do ourselves. One of the problems with regulating the internet is that the structure is not like the automotive world, right? So the car world, the thing about it was that cars are in a place, and the roads were mostly publicly owned. But neither of those things is true on the internet. The infrastructure is mostly privately owned, and of course, the way that the structure works, the network of networks and so on, means it is very hard to know exactly whose behavior it is you need to change. So there are things, however, that we could do that are built on this kind of system. We could ask ourselves whether devices or applications or whatever could advertise the kinds of traffic they want to send or whatever. We could try to get applications to work in some kind of scope so that you know whether you're supposed to be inside this network or not. These are general questions that I have. I don't know what the answer is. I noticed that HomeNet, which met today, is working around these kinds of things, right? What we're trying to tackle there basically is what you do for people who have a network that is effectively completely unmanaged, but it wants to be like really super sophisticated. It could be that there are various kinds of feedback mechanisms that we want. I will note that for instance, source quench doesn't work anymore, but maybe you need something like that. I don't know what the right answer is. I'm not proposing that we revive source quench, so please don't get up to the microphone and tell me that. I guess the general thing that I want to point out, however, is twofold. First of all, we have to be very careful here because it's really easy to propose simple solutions that actually just invite a new kind of attack, so we move the problem around. And I've already heard people complaining about DNSSEC in this way, right? DNSSEC solved the problem of spoofing, and it solved that by making the DNS an excellent amplifier. And so maybe this is something to think about. The second thing is I believe that if we do not think about and answer these questions ourselves, somebody else is going to answer those questions for us. And it's not going to be answered in rooms that look like this. No t-shirts are going to be involved. So not all regulation is automatically bad, and I want to emphasize that, right? The fact of the matter is that the automotive industry was not putting seatbelts in cars, and there's lots of evidence to suggest that wearing your seatbelt during a collision makes it less likely that you're going to die, and that seemed like the sort of thing that would just be obvious. Okay, so we'll put seatbelts in all the cars, but the automotive industry wouldn't do it. That was, in fact, what Ralph Nader's complaint was. That the industry was more interested in, its own profits than it was interested in spending a few $100s a year per car on improving safety, or durability, or efficiency, or the pollution state, or something like that. And so what happened is that the regulators stepped in and did it. The problem with this kind of regulatory environment is that it causes long lead times, and it creates perverse incentives. One of the interesting things about the North American automotive market is that the rules were different for cars and trucks. So what we saw was this explosion in light truck traffic on U.S. and Canadian roads, and the reason for that was that the incentives were set up so that the automotive industry had a reason to push those things. So we want to be careful about that, and that's the reason that I say we are the people who ought to tackle this problem. We have to tackle this problem because we understand the technology, we understand what the incentives are, and we understand the nature of the underlying thing. And if we don't do it ourselves and we don't tackle some of these perverse incentives, somebody's going to come along and do it for us. So I don't have a magic solution for you. I wish I did, but I hope that this has been a little bit of food for thought, and I hope that we can have an interesting and useful discussion here in the IETF plenary. All of you are smarter than I am, so the chances are good that you're going to be able to come up with something better than I would anyway. Thanks very much.
Wow. So while everybody's thinking about that and thinking about your questions, I'm going to put Yari on the spot. I need a time check because I forgot to ask. How long do you think we have for? Okay. I guess you're first. Center mic.
Olaf Kolkman. Question to you, Andrew. What you just described with the car example was Nader pointing to existing solutions that were not implemented by the market. The seatbelt was already available, as I believe. I think that we are in a different situation here. We don't seem to have the fundamental solutions.
Does this work? It does, okay. It just doesn't have a little light, so I don't have an indicator. So it's true that the seatbelt was something that, that already existed, but actually Nader's book is really instructive. I like the automotive example just because it's so transformative, but you can find this in other kinds of industries. Actually, Nader's complaint was not just that they wouldn't implement stuff that was known already, but they wouldn't do any research on alternatives either. So they weren't working on other kinds of stuff. They weren't trying to find new things. They weren't trying to make the car more fuel efficient or safer or anything like that. And I think that both of those kinds of things are going to be important, both for our industry and for other industries. But I think, you know, we're the ones who can talk about this one.
Okay. Far microphone.
Mr.
Front, stage left.
Kathleen Moriarty, SecAD. So, Andrew, I wish you were, I hope you're right that this is a turning point, but evidence looking out at interest in system hygiene, it's, you know, for IoT, it's not there. For open source, you know, if you talk to leaders of open source efforts, they're literally saying, you know, and exclaiming that security will come later, right? So even these big efforts that have leaders who have seen things fail, having not had security built in from the beginning, are still proceeding in that way because they think features first matters. The other thing, we have a working group here called SACM, and it's moving really slowly, and they're working on being able to validate system hygiene, but there's not wide interest in it, right? There's not a slew of vendors in there. There's a few people from the customer side. How do you see this balance of you think we've reached that point, but we have all these other factors that point otherwise?
Well, so sometimes the answer that people give me when I get gloomy and doomy like this is they say, well, that's an economics problem, not a technology problem. And my response to that is that if you think that technology problems and economics problems aren't the same problem, then you're missing the point. That in some fundamental way, either we figure out how, amongst ourselves, how we're going to do this, or somebody will come and tell us that we're going to do it. And I think that's the point that I'm really trying to make here, that we have lots and lots of evidence in every industry that if the technology becomes important enough, other people will come along and tell you what to do. And this is especially true in the Internet of Things area, because most of the so-called things that people are hooking up are already regulated, right? The light switches and the light bulbs and the toasters and the refrigerators and everything like that, they're already electrical authorities who are just dying to extend their power into the network. So I think that we have a self-interest here in our industry, and we're going to have to figure out how to convince our collective industry that we need to put the money into this. Now, one thing that we might want to do is redefine, at least at the standards level, what we might want to do is redefine the way we tackle these things, so that instead of talking about features versus security, we actually talk about features exclusively in terms of their security properties, or at least partially in terms of them. And we could do this maybe by thinking a little bit about how we describe this in documents. Because today what we do is we have, you know, this long document that describes all the features, and then at the end we say, and by the way, these are the security properties of it. And if we could figure out a way to distribute that through our documents, maybe that would help. I don't know.
Okay, so that just hit a trigger. I mean, if anyone's interested in helping on data models to validate security of different device types, whether it's Yang or something else, SACM's going to be open to, it is open to contributions, but they're also very flexible on what is used to do that validation, knowing that different device types will use different interfaces, and so they have to be accommodating of that. And that's one way to get towards hygiene and automated checking of it. So help is welcome.
Okay, I'm told we have a remote. Go ahead.
Hey, good afternoon, good evening, everyone. This is Elliot Lear. First of all, I want to thank the IAB for putting on a really great technical topic. It's really well done. Congratulations to Kathleen and Andrew and the rest of the IAB and the other speaker from Cloudflare. I just wanted to say that, first of all, I really enjoyed your presentation, Andrew. I'm also the person who wrote out MUD, with the manufacturer usage description document, which you can find in the Ops Area Working Group. I think, Andrew, that your point is that there's room for everybody to be part of the solution here. So what is it that endpoint manufacturers need to do? What is it that router and security manufacturers need to do? What is it that governments need to do? And what is it that consumers need to do? And I'd suggest that the IAB is actually in a very good position to write out some advice along those lines as we develop new technical solutions. And I couldn't agree with you more that if we don't do it, others will, and they'll probably do it poorly. Thank you very much.
No, I don't think so. Did you want to comment? Thank you, Elliot. Back to the center microphone, please.
Okay,
Bye-bye.
thanks. Juan Carlos, well, my comment is actually following up from Elliot's. I think he's got a point that nowadays we have evolved. So we can learn definitely from the past, and the examples you gave about the automotive industry are very valid. But we can also learn, for instance, from the IANA transition that moved to a multi-stakeholder idea. So I think, and I wouldn't agree that we are in the best position, but not only as a technical community, but also representing manufacturers, the commercial, the civil associations, and so on, because we need incentives. We need to make this thing work, and it's in everyone's interest. So instead of promoting the alienation that lately is happening a lot between, no, this is my realm, that's your realm, we're different, we don't speak to each other, I would actually encourage us trying to get these communities work together and basically make the internet work. You got a point, and the fact that you say this is a different idea, it's not public, it's private, public, civil, individual, commercial, so we have to think of it differently. Thanks.
Thank you. Left-hand microphone, please. Yeah, the center. Thank you.
Thank you. This is Hannes. I think it's a good idea, as Andrew said, to start the dialogue, but as you have put up on the slides, the solutions on that, or the only solution you mentioned there, is one that is quite natural for this type of community. You have network equipment manufacturers in your IAB, and so the solution is, of course, you have a firewall in the network that filters traffic. And that illustrates the problem. While you say we need to reach out or you need to be inclusive and so on, you actually need to get these other people on board because they are currently working on all different venues. And specifically, there are very few chip manufacturers in the IETF who could contribute this. Also from the rest of the value chain of that industry. That makes it very difficult to come up with a solution that they would even recognize. Richard Barnes and Keith Moore and myself have put together a document that focuses more on the security of the IED device itself. And if you look through it, you will notice that it's actually not so easy to come up with some recommendations that could potentially be enforceable by a regulation in the hopefully better style of PCI DSS. And so I encourage the IAB to reach out to those other stakeholders and not just to look around the usual suspects who obviously see a great opportunity to sell some new firewalls. Because I don't think that alone will sort of solve the problem, if it will solve the problem at all, because those parties who had not been interested to use any security mechanisms, they will hardly be interested to implement or even know about this other security mechanism. So it's like, it sounds a little bit bizarre when they haven't done the obvious thing. Why would they do like manufacturer certificates with some new innovative description with some firewalls in every network?
So I'm really glad that you pointed out that there are multiple ways or multiple levels that we got to tackle this at. And I agree with you. I was sort of trying to keep the the examples light, just because I mean the potential here is very wide, but I think you're exactly right that we don't want to use only one strategy. And this was part of the reason that I was so happy that Nick was here to join us, because it's nice, for instance, to have an operator speaking at an IETF meeting. I think that's a thing that we don't get often enough, and so like we're all going to have to do this, and I think that you're precisely correct about that.
Thank you. And I think the left microphone is next. Oh, do we have a remote? Okay, then I think you.
Is that me?
Yes,
or
that would be you.
Okay. Henning Schutzwani, I spend my days in Washington these days, and the notion that you can just say, oh, we'll solve it next year, or after the next big one, or whatever. I mean, we've had similar problems on PCs, on mobile devices, and most of those are not protocol problems. It's not like somebody discovered a vulnerability in a crypto algorithm or in TLS or whatever. These are just pretty dumb implementation problems, as in hard coding passwords is not exactly a BCP level thing that we need to write up. And I would bet that none of the manufacturers that were involved in that particular botnet, recognizing that this is just one instance, are presented or have ever attended the IETF, and are unlikely to be quite honest. And the exhortations from the day isn't going to change their behavior. I mean, that's just recognizable, and I think government people are smart enough to recognize incentives, and currently there are none. And Hannes mentioned PCI DSS, and I think that's an instructive example where, in case you don't know what it is, it's where if you accept credit cards on your web server, you have to get certified. Every month somebody pokes your web server and makes sure that you have implemented all the CVE remedies that are there. Otherwise, you don't get to accept credit cards. That's not a governmental thing. That's because we have two big entities, Visa and MasterCard primarily, that control that particular thing. I'm not sure that's a better option in that. So I do encourage people to come talk to government agencies. I certainly be happy to talk to people. I do advise that we will solve it somehow at some point indefinite in the future with some magic is not a good starting point of that discussion. Because usually that means somebody in the political realm will have to take the blame because they haven't done anything. And they're usually much more visible than the people in this room, I hate to say. So solutions are very much, this is a fertile time for proposing solutions, but there can't just be, oh, we'll all just sing Kumbaya in a room and we'll all just get together and we'll solve that magically, simply because there's no evidence that it has worked for the past 20 years.
Yeah, this is absolutely true. Anybody who thinks these problems are new should go back and read about what happened when people realized that there were going to be cable boxes always on the internet. I'm going to close the microphone lines now because we still need time for the IAB and IAC, ISG, but center mic.
Dave Crocker. So thank you for this session, not just timely, but nicely done. And I think you raised some basic questions that we then have the challenge of figuring out not how to answer as much as how to talk about. And I think the kinds of questions and issues you raised point in the right direction of trying to understand how to talk about that. So for regulation, I liked that you distinguished between what really are two kinds of regulations. The low-hanging, relatively easy fruit to at least think about is requiring use of things that already exist with known efficacy, benefit, cost, and all the rest of that. One might call those standards with teeth. The other are the aspirational ones, thou shalt eventually reduce pollution by some amount. Those only make sense if we have a good basis for believing we know how to achieve those. Even if we don't know now how to, we have a skill set that says we're probably going to be able to. For much of this topic, my sense is we're not there. We need to be, obviously. The low-hanging fruit I characterized as standards with teeth. One of the challenges of regulation in this space is there aren't that many bodies with the scope to do regulation across the entire internet. for enough of the things that might need regulating, never mind that we don't have consensus on what the regulation should be. A comment that was just made hints at a point that we need to keep in mind. The internet has been under attack many times at the architectural level. They weren't necessarily malevolent, some of them have been, but many of them have not been. We have exceeded limits, we've exceeded styles of use, and we have broken things. NSFNet broke the backbone routing service. In fact, it was being broken periodically, but NSFNet institutionalized it and forced the creation of BGP. In the late 80s, and I think there may have been more than one of these, but there was a burst of activity to deal with TCP congestion, to deal with certain kinds of efficiencies, and there was almost a cornucopia of efforts, some of them very disciplined, some of them very narrow. We don't really have an equivalent marketplace of what really is research. It's very focused research, very practical with a goal, a very near-term delivery. And the discussions that surrounded that, I mean, it was pretty cool in those days to come to an IETF meeting and watch the various proposals being talked about and justified. And that's what we need to, I think, move to pretty quickly.
Thank you. Next at the center mic, and then I'll go back to the left.
Tiffany?
Yeah, please.
Yeah, hi, Bob Hinden. Yeah, thank you again for doing this. This is very topical and important. I'm actually personally pretty terrified about this. I agree with one of the Sullivans up there that this is just the beginning of something and it's only going to get a lot worse. I think the IETF needs to do something, you know, because it's easy to see that regulation could happen, but I don't think anybody knows what the regulation would do. And it's particularly hard, I think much harder than the car example, because the internet is so international, is that you could have, just for example, have good regulations in Canada, but then you're going to get bot attacks from the US, or, you know, substitute any set of countries. So unless it's all fairly uniform, it's not going to help too much, or at least as much as it should. So I think we can do a lot to help. I think a lot of the problem here is in having endpoints that don't get turned into botnets. And I think we can, besides making the protocols better, I think we can also write words down, you know, have best current practices of what reasonably secure devices are, and then that'll give people who build them or sell them, or if they have to regulate them, have something to actually look at to base that on.
Thank you. Far left microphone, please.
Tom Herbert. So I'd like to give one example in the open source community where we're trying to address part of this problem. So I believe Nick mentioned that Cloudflare was using IP tables and BPF, and we're getting about 1.2 million packets per second drop. Over the past year, we've actually been looking at this. That number is really pretty bad when you think about it. And we can increase that by tenfold with something called Express Data Path, XDP. And it's kind of interesting because we've been working on this and people kept asking us, why is a packet drop so important? Why are you focused on this? Well, it's for denial of service, and hence we have this discussion. So I think that kind of validates where we're going with a lot of that.
Thank you. Thank you. Center, please.
I'm James Woodyard. My ears perked up when I saw that slide that talked about the you must be this tall to ride problem. And I know this is a discussion about whether the internet architecture itself might be potentially a thing that is something you could point fingers at as this is why we have so much risk in our system. And I think to myself, okay, so what are the architectural features of the internet that make it so that it's a playground for asymmetric warfare, right? And the first thing that comes to mind there is that, well, some years ago, I was the technical editor for an RFC that described the simple security characteristics of residential gateways, where the idea was unmanaged home networks, but gosh, they have to have a firewall that is completely unmanaged by people. And I worked on that despite really not wanting to, because from my perspective, I wanted there to be, a transparent ability to get in and out of home networks so that it was possible to build applications that you didn't have to be running a secure data center with lots of centralized pipes. You could distribute data around the edges of the network and maybe have another way of making something that was robust against distributed denial of service attacks. I'm not sure whether that's necessarily a way to solve this problem, but we kind of built an architecture that says, no, that's not going to be possible at all. We always turn on firewalls that block incoming connections from, unexpected remote addresses. Arbitrary remote addresses can't get through these firewalls because they're always turned on. And it seems to me like we sort of did that on purpose. I don't know how we can change that part of the architecture, because there seems to be like widespread consensus that this is all good and that's what we have to do. But it's the thing that makes the internet an asymmetric warfare playground. So if we're going to live in a world that's forever going to be asymmetric warfare until the end of time, maybe we just kind of have to hope that people who do policy and regulations will tell us how they want it regulated, and then we can build technology to apply those policies. But we're not a policy development organization here. We're just like engineers.
So yes, but I think you put your finger on something here. So I think you're right that we made an actual decision at some point to change the right. We pretend that we've got this dumb network with all the intelligence out at the edge and so on. And then if you look at it, actually, we've got classes of network that are in there. So it's already false, because you've got access networks versus infrastructure networks and providers networks and so on. And these are really different classes of network. They have different properties. And we sort of pretend to ourselves that they're all the same, but they really aren't, at least the way they're deployed today. Mm-hmm. The deployment is not really, it's not really completely separate from the architecture, right? That there's this idea that you've got the architecture and then you've got this completely separate thing of deploying it. And I think that's sort of lying to ourselves. But what this means, of course, is that we could decide that what we wanted to do was build protocols that tended to distribute data in a secure way instead, and tended to push things back out to the edge. Now, maybe we got to do that in a network that doesn't allow the sort of arbitrary point-to-point connection that the original internet model had. But if we think about this in terms of the kinds of services and data that we push to various places, it could be that actually what we would be doing is recreating that older feature. And the reason to do that is because the purpose of all of this was to get the data moving around. And so maybe what we've got is like this hangover of this kind of kludgy middle thing with all the firewalls in between and so on. And yet you still might end up with the properties of pushing the things out to the edge so that the applications that are living out there on the edge would have the local freedom to do these kinds of things. I don't know how all of that sort of picture of the future plays out, but it seems to me that if we started thinking about alternatives to the way we've deployed stuff that looked along these lines, and actually turn our gaze to a system that was there in the past, we might learn something from it, and maybe we could recreate some of the advantages that we had before.
Will the IAB be taking up this this question in its challenge in its future deliberations?
That's an excellent question. I guess the IAB is going to march up here in a little bit, and you can grill us about whether we've really got a plan for this. I can say that I do not have a plan for how to do this. This is like a bridgehead thing that I've got here. I've got this idea. Here is the sort of problem that I have, and I know I've gotten this far, but it seems to me that if I look out that way, it's a different picture than if I look out that way. And maybe I can figure out which way to go next.
Thank you for making this presentation.
Thank you. We're running a little bit short on time, but we're doing okay. And Eric, you're next.
Eric Nordmark. So I think it's clearly that from an operational sort of the scale of the internet, the thing you talked about in terms of the focus on how do we cope with these attacks, right, or these sort of malicious load spikes, that's something that we have to figure out how to get better at. But as people point out, this is asymmetric, right, in terms of the cost to the attacker versus the cost to defend against it. If you have these things with admin, username, password, the cost to attack is close to zero, right? So I think that, yes, we don't actually build those devices that sit at the edge, but maybe we have expertise here in the IETF in terms of what's the sort of state of the art, what software can be used. If we invite those people and show them some running code, right, maybe we can help move that side forward as well. Because I think that we should figure out how we can look at the whole end-to-end part of the puzzle and not just only look at how can we defend it inside the network. And then we might be able to get to solutions quicker here. Sure, we will still have attacks, right, of various forms from various devices, but we can move the whole front forward as opposed to only moving one half of it.
Thank you. Center mic, please.
Lorenzo Cooley, two things. First of all, for the NAT64 network, so the IAB recommends that all networking standards assume the use of IPv6 henceforth and be written so they do not require IPv4. I would posit that if we're here at the IETF to do work, then that's what the default v6 only network should be. So we should make the network NAT64 by default, because that's what we're trying to do here. We're trying to design protocols. So with that in mind, another thing. So if we want, we like end-to-end, right? And if we want the internet to be end-to-end and we want it to be secure, then the security has to be at the edges, right? Otherwise, we can't continue the existing model. Now, before we throw away the model, we should try to fix it. Now, the observations here is, I think, the security models of, I don't think any of our protocols are broken. I don't think we can fix any protocols to fix this problem, because the protocols aren't the attack vector. It seems to me that the attack vector is code that nobody cares to update because they have absolutely zero incentive to update it. Now, it's like, so I write code that goes into Android, right? And, you know, it's a billion devices, and manufacturers update it, they don't update it, maybe they update it, maybe they don't. For an IoT device, there is absolutely zero incentive to put any security at all in your initial build, because it means that you're going to be behind somebody else. And I don't see a good way around that except to say, okay, you must be this tall, you know, to connect to the internet. Now, what would our role be in that? Our role might be to say, okay, here's a protocol that we can build so that a device can say in a secure way, here's the latest security update that I have, and it's signed by my manufacturer's key. And I support all these CVEs and I fix them. And so after a while, once we have that trusted attestation, we can say, okay, well, okay, here's a bunch of bad devices, and we can try to decide what to do about them. And that's a technical solution. It's not attacking a problem, but it's providing a means that somebody could use to solve the problem in ways that are not going to necessarily change the model completely. Right? And so, I don't know. What are your thoughts on that?
Well, I mostly agree with you, but I have a little quibble, I think, with one of your premises, which is that like the protocols aren't broken. So I agree with you that individual protocols, maybe accepting the DNS, are not broken in their fundament. But I think what I am partially arguing is that what we've done is we've designed a system which has as its property this basic vulnerability, and the solution to that cannot be, well, we need the endpoints to behave correctly, because if you're going to design a system in which there's no barrier to entry, and you don't have sort of access controls for who gets to come on, then you have to assume that some of those people are going to do bad stuff. And so the model that we had was a perfectly good one for a network where you could write away to the Network Information Center and get a list on paper of all of the humans that were connected to it. But we passed that thing some time ago, and we haven't done anything about our model of who gets to join. And I think the problem that I'm worried about is that the network doesn't have any other protections against this. It's really just got like, once you're in, you're in. Our bodies don't work that way. You get through the skin and you're still going to be like, defended against. Whereas what we've got really is you get through the skin and hey, you're wide open here. And that seems to me like a difference that we could do something about if we adopted a sort of immune response sort of environment to this. So I like the suggestion that you make, that what you could do is say, hey, wait a minute, we've sent out this inoculation against this problem, and you're not behaving like you're inoculated. Well, we can then identify you. So there might be something in that.
On the protocols, no protocol is broken if it doesn't survive a 2,000 to 1 attack. I mean, that's just not in the design space, right? You've got 1 million hosts trying to attack 10 machines. What are you going to do?
Yeah, so I'm a little bit more tempered on that. I kind of agree with you that if we can build software or do work that makes it easier, cheaper, and reduces the friction for people building these devices to have security by default, I think it doesn't solve things in a 100% case, but the more security we have, the better. And that's sort of one of the main points of my presentation is that it is about scale. It's, you can handle something that's 10 times bigger, maybe not 100 times bigger. If you can reduce the problem, then that's better than a lot of things that you can do.
Yeah, maybe we can at least reduce the asymmetry. Next, please.
Yeah, my name is Georgios Karagiannis, and I'm working for Huawei. First of all, I would like to thank you for this interesting and important session that you organize. In addition to that, I would like to mention that in addition to the security challenges that you have discussed that somehow stimulate us to think on redesigning maybe the internet architecture, there are also other challenges that are related to privacy. So protection of personal data, and then data ownership, and in addition to that, you mentioned regulation. The European Commission, the European Parliament is actually working on the General Data Protection Regulation. So they have already defined a certain regulation on privacy, and there are also gaps on technology. So. And this might also stimulate us to think also in that area. So in addition to security, also privacy type of topics.
Okay, and you get the last word except for me.
Hi, Roland Dobbins, Arbor Networks. I mitigate DDoS attacks for a living, and unfortunately, business is very good. A couple of comments. There are a lot of best current practices at all 7 layers of the OSI model and at the entire communications chain across the internet, that if we could wave our magic wands and have them implemented immediately, the asymmetries that are so heavily in favor of the attackers right now would be greatly reduced. We would still have a DDoS problem, but it would be much more manageable. With regards to regulation, I'm a big fan of what's called backdoor regulation. And what I mean by that is there are regulations in place having to do with things like insurance, for example, different types of insurance that organizations have to carry, different types of policies and levels of policies that they have to carry because of laws and regulations that are often transnational in nature. I just had a very interesting conversation with a very large insurance underwriter, and they wanted to talk about their authoritative DNS and what their risk model was. And we had a good technical and operational conversation. But I told them, I said, you know, I'd really like to have an in-depth chat with you about your, quote, cyber, unquote, policies that you're writing, because I think you have a lot of unsecured risk that you're on the hook for, and that you and your friends in the actuarial associations really need to be briefed on this. And so I think that that's one way to get in some backdoor regulation, essentially through the insurance underwriters, to let them understand that they need to start really auditing organizations that they write policies for. Another comment I have in terms of regulation is that governments actually have a fantastic way to regulate without regulating, and it's called the RFP, the request for proposal. Governments can specify vendors that they purchase things from, services from, including things like internet transit and so forth. They can specify that verifiable steps have been taken by those organizations to implement reasonable best current practices that the industry recognizes. So I would encourage folks to cozy up to your local insurance actuary, to cozy up to your local purchasing folks in government and talk to them about this, because there are ways to get regulation without actually regulating. And I think that we really need to take a very strong look at that in addition to all of the different types of technological things we're doing. And finally, large jury verdicts are also a good incentive to get folks to do things. And I think that there's a lot of education that needs to take place in the legal industry in various countries because there are doctrines like attractive nuisance and various forms of negligence that I think would apply here as well. And so while we're all working towards improving the technological situation, I think that we need to attack this problem, which is ultimately, it's a social problem, from the social side as well. Thank you all very much.
Thank you.
Suze, I just had a quick question to relay from Jabber, which is brief and I think worth relaying. And the question is from Elliot Lear, and it's where can we carry on this conversation? Which mailing list? Will you set up a mailing list?
Arch discuss?
Yeah, so there is an IAB general list, Arch Discuss, that is open for anyone, and if we want to talk about big architectural things, that's a good place to do it.
Yeah, I was actually literally just trying to remember exactly the answer to that question, so thank you. We have run a little bit long, but I think this has been very, very good, very substantive. We did answer the question of where to continue the discussion, and I hope everybody will forgive me a shout out to my dad, who I think is really going to enjoy the archive of this discussion when he's feeling better. Thanks, everybody.